Lindner?
From the, no, Fraunhofer.
Fraunhofer ISI?
ISI,
Yeah. Same.
yeah.
In
Yeah,
the same group.
Yeah.
So should I come with you or?
Yeah, you can stay here. Okay, welcome to this fringe session. Now we can be ready to begin. I think that this could be one of the most important sessions and topics of the whole conference. Sorry if I'm a bit provocative, but these kind of topics are the one that lots of scientists tend to underestimate. But, especially for the success of graphene, for the success of the flagship, we can do the best transistor, the best batteries, the best whatever in the world, but one single negative article on toxicity or misuse, it will be enough to kill completely this application, to scare industries. We have seen these examples in, luckily, a smaller case for nanotubes that some news went around, and so this scared also some industries. And in the flagship, we consider responsible research and innovation very important. We have a work package that is just dealing with toxicity, health effect. We have an ethical board, because we know that it is very important that we take care of this. So that's why we decided to organize this session with two very good speakers, because we want to be sure that whatever we do here and in the project is safe for the people and makes the life of the people better. So I'm really happy to see that there are several people here. I'm really glad to introduce the first speaker. There will be two presentations. There can be time for questions at the end of each presentation. Then after both presentations, we can also have a debate. So if you have specific questions for the presentation, you can ask them after the speaker. If you have more general comments, you can keep them for the final discussion. So the first speaker is Ralf Lindner from the Fraunhofer ISI Institute, who are partner of the flagship and deeply involved in analyzing the different applications of the flagship, which will talk about, well, I don't say all the title, but it's about responsible research and innovation.
Okay. Thank you very much for the kind introduction, and thank you very much to the organizers for inviting me and giving me the opportunity to speak to you today. I'm quite excited. I've been following the Graphene flagship since it started. As just was mentioned, Fraunhofer ISI is involved since early on in the project as a partner. I never had a chance to really get involved and interact with this community here, so this is my first day together with you here. And yeah, I'm saying this also as a disclaimer, because I'm not able to really dig deep into the actual research this community here is conducting. My background is political science, and I usually work in the area of technology governance and the design of research, technology, and innovation policy. So I wasn't sure when I prepared this presentation how much information is already available in this community, and what should I explain beforehand. So I hope things will work out in a way that is useful for you. Now let me turn to the actual topic, responsible research and innovation. And that's going to be my focus for the next 20-25 minutes. When I started preparing this presentation, I remembered that from a number of survey results we conducted and we have at hand from European researchers, when we asked them, are you familiar with the concept of responsible research and innovation? We found that only about a quarter of European researchers are actually familiar with the concept. So that's why I decided, well, maybe I should give a short introduction first. What is it? What is this concept? And why could it be relevant for the Graphene flagship and related research in this area? In the next step, I want to give a short overview of the policy landscape in which this concept of responsible research and innovation actually sits. I think this is important to see that this concept is more than just a crazy idea of a few social scientists. It has actually found quite some traction at the policy level. I'll talk about that a little bit. And the second main part of the presentation will be about the process of, what can we actually do to make our research more responsible than it might have been in the past. And I'll say a few words on how this can be approached, what concepts are involved in these approaches, and finally I'll give you a few ideas where you can, if you're interested in pursuing this idea of and the ambitions of responsible research and innovation, where you can find additional information and training material. So the question, first of all, that we always run into when we talk about responsible research and innovation, particularly to natural scientists, is why? Why do we need RI? Now, the first answer is, of course, this is not about saying the research you all have been conducting so far was irresponsible. That's not what RI is about. It's actually, that's what I would argue, it's about the inherent ambivalence of any technology and any research we are doing. You always have the situation that scientific developments come with a lot of promises on the one side, but at the same time, we always have concerns about the effects of emerging technologies. And if that is the case, if technology is a problem and a solution at the same time, we need approaches and mechanisms to make sure that we are actually consciously directing research in the desired directions. And this is actually the ambition of responsible research and innovation, to make sure that research, science, technology development, and innovation are responsive towards societal demands, that we improve the relationships between science and society in order to make sure that we have a better alignment between these two worlds. Now, responsible research and innovation claims to be a comprehensive approach. That actually means it is not just about assessing risks. That's always a key and really very important part of the governance of technologies. But it's also putting focus on the question, what kind of direction should research and innovation actually take? Or phrased differently, to what kind of future should research and innovation actually contribute to? And that's kind of a discussion that has been opened up by the whole policy concept of responsible research and innovation. In terms of processes, the concept is usually connected with a number of suggestions how to maybe change the way we conduct our research. Two of the typical things that always are mentioned is more intense involvement of stakeholders, maybe even lay people in certain stages of the innovation process, and also the encouragement and the enablement of research actors to develop kind of forward-looking, responsive attitudes in their work. Now, RI is fairly new. The debate started about, I would say, 15 years ago, more in academic circles. And since then, a number of definitions have been developed by all kinds of academics. These are just two definitions that are often cited. I think it's not that important to kind of stick to one definition. I think the main point on which actually all of these different actors in the debate around responsible research and innovation can agree upon is that RI is about improving the alignment of impacts of technology and innovation with societal demands and values. In many ways, RI is not new at all, and actually it actively draws and builds on concepts, methods, and approaches that have been, in some cases, been around for many decades already. This is just a tentative list of approaches that are very similar, that share very similar ambitions as RI, namely trying to ensure to avoid unintended consequences of research and ensuring a higher degree of alignment between the impacts of our work with what the society actually is calling for. So in many ways, it's not new, but it tries to integrate what has already been out there for many years and kind of bring it to a new level. So that was a brief introduction to the RI concept itself. And then we have a policy landscape in which RI has been actually flourishing since about a decade. After this more academic debate, developing first ideas of how responsible research and innovation could look like, it actually got first traction on the level of the European Union. The European Commission started with the first calls for RI-related projects in FP7. And in H2020, so the current framework program of the European Union, it actually was firmly established as a cross-cutting theme in H2020. In DG Research, we have a dedicated unit which actually is responsible of mainstreaming RI across all activities in H2020. And in 2014, the governments of the European Union, the European Council endorsed the idea of responsible research and innovation. So that kind of gave the whole thing an additional push. Now, at the moment, things are a bit unclear, at least at the European level. We see that it's not sure at the moment which direction Horizon Europe, the next framework program, will take, and how the issue of responsible research and innovation and similar approaches will be dealt with. So we're interested in seeing how these things will develop. But RI has taken root also beyond the European Union. We see at international level a lot of initiatives that have picked up on RI. The OECD is in the process of developing a set of principles for the international level to ensure that responsible innovation principles are taken care of internationally. At the national level, we see a lot of governments that have taken up responsible research and innovation. The forerunners are the United Kingdom, Netherlands, Norway. You could also add Sweden and a number of other countries. And even the regional governments have in part started to pick up on this idea. But it's not only the policy side and the research funding side. We actually are quite happy to see that a number of industry players are picking up on the idea, are moving towards institutionalizing the concept of responsible innovation. We see a number of large corporations working in this area. We see a number of small businesses, but also industry associations like the ones I listed here. So things are actually moving forward in this area. Now, after this background information, I'd like to kind of turn to the actual question: how can we put RI into action in our research and innovation context? Now, before doing that, now drawing on some of the insights that we've developed over the years, looking at concrete RI-related activities, I think there are three lessons we can share with you. 3 points or three general considerations that should be taken into account before we start trying out things in terms of responsible research and innovation. The first point I would like to emphasize is that, as you know, responsible research and innovation is also about the question which direction research should take. Now, in my view, it would be extremely naive to think that this will come without conflicts. Now, the question which direction research and innovation should take will always be contested, and we should take care of establishing procedures and mechanisms and fora of debate to ensure that these debates are done in a constructive way, and that we have constructive negotiations between the different actors and interests involved. This shouldn't be pushed away. These conflicts are there, and we should talk about them. The second lesson is that, as mentioned previously, a number of concepts and governance arrangements, governance instruments for emerging technologies are in place. And as I said, they often address quite similar aims as responsible research and innovation. In the industry context, you have the schemes of corporate social responsibility, you have sustainability reporting, you have codes of conduct in many areas, ethical reviews, technology assessment, and so forth. Now, our recommendation would be these things shouldn't be set aside, and we don't have to start from scratch, but actually makes a lot of sense to build on these existing governance arrangements and use them productively if possible. Integrate them, if you will, into the larger picture of responsible research and innovation. And most importantly, I would say the third point is the lesson that the definition of what is actually responsible is something highly context-specific, context-dependent. So that is actually important to make sure that a research organization, a university, a department, or whatever, or a company, that they have the possibility to adopt in their own way to the spirit of responsible research and innovation. So we actually caution against the idea to prescribe top-down approaches and certain ways to deal with responsible research and innovation. Actors are actually themselves best placed to determine the specific context of what responsibility is. Now, talking about the institutionalization of RI is quite easy. Actually doing it is not. From the experience we've made in looking at a number of universities or research performing organizations, companies that have actually decided we want to go down this road, we identified a number of conducive factors that support the institutionalization of RI, and a number of barriers towards RI. Now, what is quite important and useful to have in your company, in your department, is kind of what we call institutional entrepreneur. That's a leading figure in your organization that is really dedicated to these ideas, and that's something that really helps to bring these things on the road. Then, of course, external requirements can be extremely helpful, and we know from the United Kingdom, the Netherlands, and a number of other research councils that started to include requirements of responsibility or RI in their calls for funding, that actually started to change things in many universities and research groups. Of course, the internal incentive system is something that should be supportive of the idea of RI. And we learned that those institutions, organizations that actually have experience with, for instance, RI-like-ish things like ethic reviews or sustainability reporting show much more openness towards the idea of institutionalizing RI. This is what we call RI literacy. Now, on the other hand, of course, there are a lot of barriers out there that make it difficult to institutionalize RI. One of the top of the list is clearly the problem of overload of tasks, particularly for the individual researcher and scientist. You know, you have to do your teaching, you have to do the administration task, you have to do the core research, actually. And on top of all these things, you're also supposed to do, for instance, things like public engagement activities and a number of other things. So that's definitely something that needs to be addressed and talked about. A number of researchers also report back that they would love to do these things, but don't feel really equipped to do it. So there's a lack of knowledge, a lack of skills on the side of many researchers. So that's something that should be addressed. And in some organizations, we actually see that the organizational norms and belief systems are sometimes in conflict with the basic ideas of responsibility. And then there's, of course, a certain risk that if you try to institutionalize the idea of RI without actually changing practices, but just, you know, making a kind of a tick box exercise out of it, nothing will actually change, and that's also something we should keep in mind, I guess. As I said, we conducted a larger survey on the view of RI among European researchers. We had a quite a wonderful response rate, actually, with over 3,000 responses in this survey across Europe. And we were actually quite surprised to learn that a large majority of the European researchers are quite positive about the concept and actually see a lot of scientific benefits, or at least expect a lot of scientific benefits if we actually conduct our research more in line with the ambitions of responsible research and innovation. This, for instance, includes the observation, or at least the hope for, the identification of new research topics. It enhances the visibility within the research community, and it also increases the relevance of the scientific output. So that's at least what the European researchers say about this. So, while I said previously that it's very important to make sure that if you, as a research organization or university department, if you decide, okay, I want to try out this idea of responsible research innovation and change some things in my department, I think, as I said, it's very important that it's up to this research group itself to decide what needs to be done. But at the same time, there is, of course, a growing demand for some guidance, some orientation on what this could be. Now, one of these very general principles that have been developed, and for instance, the research councils in the UK have picked up, are these 4 dimensions here, developed by Richard Owen and his team. It's kind of four dimensions or approaches or ways of dealing with our research. It's about anticipation, it's about inclusiveness, reflexivity, and responsiveness. And these can be translated into certain practices in your research group. Another way of trying to give some orientation of what could it actually mean to institutionalize RI, it has been presented by the European Commission, DG RTD, and their way of actually translating this abstract idea of responsibility into concrete measures are these 5 keys or key elements: public engagement, open access, gender equality, ethics, and science education. And these are the keys you actually find in many of the calls of H2020 at the moment. Now, before I come to an end, there are plenty of resources out there that have been developed by a number of projects in order, with the aim actually to support research and innovation actors in pursuing the idea of responsible research and innovation. And I think the prime resource to go is a website, a web portal developed by the project RI Tools. Just go there, and it has a huge repository of tools and methods available. Excuse me. And it actually can be searched according to your specific needs and your organizational background. So you have specific services there for companies, you have specific tools and methods there for universities, research performing organizations, and so forth. So this is definitely something that could be useful. Another source, more designed towards intermediaries, so that would be a university or maybe a larger company, is the Responsibility Navigator. That's a kind of a list of 10 different principles that should be taken into account when you kind of embark on the process in your organization to institutionalize ideas of RI. So that could be something that might be useful to you. I hope that this brief overview was helpful to some of you, to maybe improved understanding of what this abstract concept of RI could be, and maybe some of the resources that I pointed to might be helpful to kind of pursue this idea further. Thank you.
Okay, thanks. Thanks for this nice introduction. I see that we have a question there already.
I must admit I react badly to what you're proposing here. Like research and responsibility are two things, right? Research is there to explain things we don't know. And once we know something, we can always apply it in a bad way or in a good way. Like we, for example, find a new knife. That knife I can use to kill somebody, or I can use that knife to cut the bread faster. So it's like the tools, you're finding the tools, right? It's up to the society to be responsible in using those tools, number one. Number two, there are entire countries in Europe where you can only do research if they respond to a specific question in society. So I hope you're familiar with that. So that means, in a sense, it's obvious what you're saying. And secondly, you don't need concepts to make things more complex. We need to just be responsible and assure that this happens on all levels. So I encourage your work. It's very useful because it needs to be verified, transparency in companies and so on. But just to say, we need to separate things and understand how they really work. So research is one thing, and the way I use that research is something else. And then, of course, if I use highly toxic materials, even I immediately go off. Nobody's encouraged to do that. And there are some thallium composites compounds in the past found where there were superconductors, and within months the first two researchers died because it was so toxic. So nobody ever continued with research. It's somehow naturally happening. But of course there are people who forget about it or are ambitious. So we need to stop them or verify that this is somehow limited.
Okay, I will suggest if you want to also specify your name and affiliation. So this helps a lot after this session if somebody wants to contact you or if you want to continue the discussion.
So I'm not a member of Flagship, so I'm independent, and I'm a Professor Wolfgang Baxter from Toulouse, University of Toulouse.
Ah, okay.
Should I respond directly? Yeah.
Yeah.
Well, I guess maybe two points I would like to respond. First of all, I think it is a challenge that the concept of RRI is actually lumping together research and innovation. Now we have certain technology domains where a separation between research and innovation doesn't make sense, but in many ways, at least institutionally, it does make also sense because these activities are different and they're institutionally often separate. Nonetheless, the underlying idea, regardless where we're looking at, is something that seems to be universally applicable, regardless of if it's something more in the basic fundamental research realm, if it's something more on the applied side, or if it's actually already technology development in the context of industry. The idea is always to kind of enable those actors in the field and support them in actually doing what you just said, thinking about the consequences of what you're doing. Now, I know from many researchers from my own organization, Fraunhofer, but also from others, that they actually would like to perform more according to these ideas of RI, but for instance, the institutional structures do not really allow that. A young researcher is completely overwhelmed with the need to publish. That's the core thing the young researchers have to do, as we all know, and there's actually no incentive, no leeway to kind of step back sometimes and think about these things and maybe engage and interact with future users, citizens, and talk about these things. And so this is just a tiny element I'm just mentioning, but that kind of is part of the larger picture here.
Yeah, I think it's good also, besides talking about the general criteria, also to make practical examples like this of the students that are overwhelmed by the need to publish.
Amelia Padan, I'm professor of physics from Nottingham. I have to say that I share the same concern of my colleagues. But in general, when a new policy is introduced, it's because there is a problem. Is it somehow there is a perception that scientists are a bunch of irresponsible people?
Well, as I said, this is, I think I mentioned that early on. This is not about saying that, the way science has been working in the past is per se irresponsible. I would just turn it around. I think we can always become better. You can reach higher levels of responsibility. I think from the political side, one of the reasons why this whole concept actually really got so much support from research funders, for instance, is a general sense that there's a growing skepticism out there in the general public about what is being done in research and innovation, that there's eroding trust towards scientists, and also there's the question of legitimacy. Research is to a large extent publicly funded, and policymakers need to make sure that what is being done in research and science is actually supported by large parts of the population. I think that's kind of the background why this policy concept started to kind of.
But I think this question is, the question from Amalia is how timely, because in recent time there is a large part of public opinion that started to criticize or not trust scientists and experts. This could be about vaccines or OGM or whatever. So there is some part of people that thinks that maybe scientists are misbehaving, that in many cases these are really just hoax or viral news on Facebook, but we should really be careful about that. There was one last question from Nicolas there. Then maybe we can move to the other speaker and keep other questions for the debate at the end.
Okay, so I'm Nicolas Nester from BASF, which means I'm from the industrial side, and what the concerns which the other questions actually expressed, I think what really needs to make a difference between research that is, let's say, to explain things, and the thing which research in science and technology is at the moment under strong pressure, which is also to commercialize things. And as soon as we are on that pathway, we are suddenly changing in the sense that one has also to think about what does it mean with respect to consuming research resources, or with respect to energy or emissions or stuff like that. This is something you don't really need to do as long as you are working on a wafer in your lab. But this is something you need to do when you intend to bring something to higher TRL. And in a place like the flagship, where we are willing and under pressure to go to higher TRLs, this is something that becomes more and more important, even in seemingly innocent fields of research and technology. And like that, I think it's very important to be aware of those concerns and actually also to follow them.
Yeah, I don't know if this is a question, but maybe it's more a comment, and we can explore it even more in the discussion. So now I think it's better if we move to the second speaker of this session, which will talk more about safety, which is, of course, a very important thing, as we mentioned at the beginning. Of course, don't ask him if graphene is toxic or not, because it's what everybody asks him, and of course this is not a simple yes or no question. So Bengt is a partner of the flagship. As I mentioned, we have a whole work package dedicated to assessing the safety and health effect of graphene, and is one of the most important partners of this work package. Not only in the Graphene Flagship, he's been involved also in other European projects and initiatives about safety and regulation. So I really look forward to see what he will show us today.
Thank you very much. And thank you to the organizers for inviting me. It is, I think, self-evident that we need to take safety into consideration, but please don't think of today's presentation as a full meal. This is more a platter of small pinchos that I put in front of you, and then we can discuss later on, I hope. So just an appetizer, really. I start with this graph, which shows the number of publications in the field of nanotoxicology. This is from the period 2000 until now, basically, or until 2017. As you can see, there has really been an exponential growth. This graph is from a paper published last month by Harald Krug. You see the reference at the top of the slide there. Harald Krug published another paper some 3 or 4 years ago in Angewandte Chemie, which caused quite a splash, and the title of that paper was Nanotoxicology or Nanosafety, Are We on the Right Track? In that paper, Professor Krug was actually quite critical, given the fact that we have so many publications. What do we actually know? What can we say for sure about safety of nanomaterials? And he was in particular critical of the fact that in the early days of nanosafety research, materials that were tested were not really carefully characterized. So if we should identify one important lesson from the last decade or more of nanosafety research, it is that we must know the materials. I think this is now fully ingrained in all researchers in the field, and it may sound trivial, in particular to this audience, but we need to understand the physical-chemical properties of the materials if we are to draw any sound conclusions with regard to their safety or lack of safety. I also put, by the way, a link at the bottom of this slide to the European web page called the EU Observatory for those who want to find a sort of one-stop shop for information on nanotechnology in general and nanosafety. Another general criticism has been that we don't really know anything about nanomaterials and safety, and I would argue that this is actually not correct. We have learned something, and for instance, we do know that certain carbon nanotubes are to be avoided. They are highly toxic. They may even be considered to be asbestos-like. But we also know that there are a wide number of other carbon nanotubes which don't behave like asbestos. Now, this was summarized in a report. The slide you see here is simply the summary of that report published by IARC, the International Cancer Union. And the conclusion of that report is also stated here in this slide. At the time of the report, this is now a few years back, there was one multi-walled carbon nanotube on the market, designated as multi-walled carbon nanotube number 7, which was classified on the basis of the available literature, mainly animal studies, to be possibly carcinogenic to humans. That means group 2B. Whereas all the other single-walled and multi-walled carbon nanotubes were not classifiable as such. What is so special with multi-walled carbon nanotube number 7? Well, it's both long and rigid, and essentially behaves like a classic fiber. So this is perhaps lesson number 2 from nanosafety research. We shouldn't forget about classical toxicology, which states that long and biopersistent fibers are more likely to be pathogenic. However, in the intervening years since this report, we have also understood that life cycle perspective is very important. And I give you this paper as one example. This is a paper from a group of scientists at NIOSH in the United States, National Institute for Occupational Safety and Health. And this is quite an important study, conceptually and principally important, because what the authors have done here is they did animal studies to evaluate toxicity of multi-walled carbon nanotubes, and they used the as-produced multi-walled carbon nanotubes, and they confirmed that they caused pulmonary inflammation in mice. Then they used multi-walled carbon nanotubes with a polymer coating, and in the third case study was to take composite materials with embedded polymer-coated multi-walled carbon nanotubes. They sanded those materials to mimic a process of use and wear and tear of the product. And they took the respirable fraction, essentially the dust collected from the sanding process, and they gave this to the mice in the study. What they found, the bottom line is that in this third scenario, they found no pathogenicity, no toxicity in mice. So the conclusion is at the top of this slide. While, in principle, if you think of the life cycle of a product or a material, while the number of people who are potentially exposed to the material, consumers and workers, increases during the life cycle of the material, in fact, what this study showed is that the toxicity is reduced along the life cycle of the material in this particular case. And I think this is important, so that's another lesson from nanosafety research. We cannot study only the pristine as-produced materials. Well, we can and we should do that because this may give us an understanding of potential mechanisms. But to understand risk for the human population, consumers and workers, we also need to consider the life cycle of the product and the fact that the material may undergo transformation from production to disposal. That particular study was a US study, but there has been an enormous investment in research funding and research efforts in Europe as well, in particular during the 7th Framework Program. Now this graph actually illustrates the fact that there have been 50 nanosafety consortia funded in FP7 alone. There were some nanosafety projects funded also in FP6 and FP5. There are certainly new projects in Horizon 2020. But during FP7, there were 50 projects, large and small. They are shown in red. And shown in yellow are those partner institutes that actually combine these projects. And it's not surprising that we have the JRC here, for instance, being a partner of, I think, 18 of those 50 projects. There are a number of other famous institutes, the University College Dublin, IOM in Edinburgh, and also, interestingly, several Nordic institutions, the Nanosafety Center in Copenhagen, the Finnish Institute of Occupational Health in Helsinki, and our university here, KI, in Stockholm. So there has been a great deal of work in this field, and I direct you to this webpage, nanosafetycluster.eu, for further information. One of the outputs of the nanosafety cluster of research projects was this report shown on the left on the screen here, which is a strategic research agenda for nanosafety research in Europe, for the looking at the period 2015 to 2025. This was published in 2013, so it's already somewhat dated, but you can find the document online as a PDF file if you are interested. I would say currently the most relevant and most illustrative document and more up to date than the strategic research agenda is this ProSafe white paper, which was published last year. The ProSafe white paper is basically the final product of the largest nanosafety research project funded by the European Commission, the so-called NanoReg project. I'll describe this more in the next slide. Finally, at the bottom of this slide is a reference, a review article that we published this summer in Nature Nanotechnology, which tries to give a perspective on the last decade of, in particular, EU-funded nanosafety research. And we also try to emphasize, it was our ambition to emphasize the fact that we now know a great deal and we have new and advanced tools for nanosafety research and assessment of nanosafety. So just to point out that there has been a great deal of work and some important results as well. Now this slide is a little bit heavy, but this is actually the first paragraph of the ProSafe white paper. And I think it encapsulates quite well the conclusions of the so-called NanoReg project. So NanoReg was a very large project, 85 partner institutes participated, and ProSafe was basically a follow-up project which tried to capture all the information from NanoReg and in the end produce a white paper. You can find all of this information at via the link at the bottom of this slide, nanoreg.eu. Now, basically what they're saying, the authors of this document are saying is that it's still difficult to regulate nanomaterials. And why is this? Well, according to the ProSafe white paper, this is because research has been science-oriented and not regulatory or regulation-oriented. I think I'm not surprised, and we have been involved in this business for the last 10 years or more, and I would agree that in the beginning of FP7, there was a lot more emphasis on mechanistic research and basically, I would say basic research on how nanomaterials interact with biological systems. I would also maintain that this is still important. We need to know more about these basic nano-bio interactions. But it is clear that there has been a trend over the last decade towards more regulatory toxicology type of projects. And if I reflect a little bit on the Graphene Flagship, I think we see a similar trend, most likely in the flagship. The first half of the project has passed, as we all know, and in the first half of the flagship, work package 4 has done a lot of basic and fundamental work on nanobio, or let's say interactions of 2D materials with biological systems. I think as we go forward, we actually need to take into account the regulatory aspect as well, and this is something we see in nanosafety research in general. There are some other conclusions here, as you can see. The fact that not all traditional tests may be relevant for nanomaterials, and so it's not that we lack regulations for chemicals. We have the REACH regulation in Europe, which covers all chemicals, and therefore, in principle, also nanomaterials. Also, as of April this year, April 2018, there are now provisions in the REACH legislation which take into account nanomaterials, and this will be in force as of January 2020. So it is actually covered by regulation. The point here is that we have a regulation and we have test methods, but the question is, are those tests applicable for all kinds of materials and not only traditional chemicals? Finally, at the bottom of this slide, you see that in the ProSafe document, they also emphasize the importance of the life cycle perspective, as I just mentioned. The NanoReg project, as I mentioned, with 85 partners, also several international non-EU partners, has come up with a proposal for a nano-specific risk assessment process, which is illustrated to the right, and the reference is shown at the bottom. I'm not going through the details. But what I want to say is that both NanoReg and ProSafe and the current Horizon 2020 project, NanoReg 2, also emphasize the concept of safe by design. And this is covered in this very recent review article in Nanomaterials by Krogelo et al. Safe by design is a very popular concept, and obviously we are talking about designing of materials such that those properties that drive toxicity are designed out. But I think we need to keep in mind that it's really only of limited academic interest to make a material entirely safe. It still has to be functional. That's why they are produced in the first place. So let's not forget that part of the equation. Safe by design means to make something safe while maintaining their functional and useful properties. Now, we are involved in one such project. This is BioRima, which is a Horizon 2020 project. And this is perhaps another trend that we see in nanosafety research funding in Europe. FP7 was sort of the golden era of nanosafety research per se. And we learned a lot of valuable lessons during FP7. What we see now is nanosafety linked to applications. And this project, which is a nanosafety project, is not funded in the nanosafety within the frame of nanosafety calls. It is funded within the field of nanomedicine. And basically, we aim to look at the fate and exposure and potential hazard and risk management of biomaterials or nanomaterials that are intended for use as biomaterials for clinical purposes. And we take into account the whole life cycle of these so-called nanobiomaterials. And the project has over 40 partner institutes and more than 20 in this work package. And I'm the lucky work package leader of that work package. And just to give you a sort of a glimpse of the ongoing work. Now, we have also within the Graphene Flagship a work package dedicated to health and environmental effects. And as you all know, and I think you're all familiar with this paper. Actually, it's not a paper, it's an entire issue of Nanoscale, the roadmap for graphene science and technology. I think you've all seen it. I'm not sure if you have all read every single page. But if you do read the section on safety assessment, you will find this statement that one of the long-term goals of the flagship and the work package on health and environment is the development of standardized and validated testing strategies for graphene-related materials to enable their regulation. So while it is important to do basic fundamental research, It is also essential, I think, this is now my personal view, but I think it's essential as we move forward that we also provide information that can support regulation of these materials. And one of the first steps that we took in our work package was this paper, which is an attempt at classification of graphene-based materials based on 3 fundamental material properties. And this connects again to what I mentioned earlier. If we are going to study toxicity of a material or any class of materials, we need to know the materials. We need to know, in the case of graphene, are we dealing with single layer or multi-layer? Are we dealing with nanoscale in lateral dimension or more macroscopically large materials? And is it pure graphene or is it graphene oxide, which is another entity altogether? And we know now from the last 5 years of research that graphene oxide behaves quite differently from graphene and certainly cannot be lumped together with carbon nanotubes. The biological behavior is entirely different. Finally, last slide, I mentioned safe by design, but I think we need to keep in mind that we as scientists also handle and produce nanomaterials and graphene-based materials. And I borrowed this concept of prevention through design from NIOSH. NIOSH, and you can find the information on this US government homepage, cdc.gov. NIOSH has, over the years, has produced a number of very useful hands-on guidance documents. I don't know if you can see the fine print here, but this is about safety programs for small and medium-sized enterprises. This is general guidance for safe practices for those working with nanomaterials in the research laboratory. And there are many other such documents. We need to keep in mind that we should also protect ourselves, our students, our postdocs, our researchers who are synthesizing and handling these materials. In our lab, we use a glove box when we handle materials in order to avoid inhalation of materials in dry form and so on. Last slide. I just want to mention that nanosafety research is an international enterprise. I happen to be chair of this scientific board of the Swedish National Platform for Nanosafety. I previously chaired working groups in the European Nanosafety Cluster. There is also a US-EU platform for this topic. So final point and final lesson maybe from nanosafety research is that we need to engage with international colleagues and partners. If the aim is to standardize testing strategies, then we certainly will all benefit from an international dialogue. But I think that in the case of graphene research and safety of graphene-based materials, the flagship should take the lead, and I think we are in a good position to do so. Thank you.
Thanks very much. Now that the time is open, we still have a few minutes for questions on this topic or general comments on or so on. Well, so any question, any comment? Something was done already in the past. Well,
so we have a session tomorrow morning which partly follows up on this theme, and you are welcome to attend and to discuss further tomorrow as well.
Well, I think what we can say and what is encouraging is, from what I understand, that the main toxicity mechanism of carbon nanotubes is when, as you said, when they are rigid and very long. And if we think about graphene, I mean real graphene, so monatomic or even few layers graphene, it can bend, it's much more flexible than any kind of nanotubes. You can really wrap it around even small particles. So that it's at least encouraging. I will not ask you if this means that it's not toxic, but it's truly encouraging. Then I'm pretty sure that there are other mechanisms of toxicity, but from what I understood, the main issue for nanotubes was that one.
That's correct.
There was a question there. Wait for the microphone. Please, if you want, give your name and affiliation as well.
Ulla Vogel, National Research Center for the Working Environment in Denmark. So this is just a comment that even though graphene is likely much less toxic than carbon nanotubes, toxicity is a question of dose and potency. And so carbon nanotubes are like asbestos, so they are really, really toxic, but less can do it. They're also worrying at less toxicity. Carbon black, which is a particle that is corresponding to graphene, is still considered possibly carcinogenic. So I think there's still reasons to be really careful and to avoid occupational exposure. So I'll be talking tomorrow, and I'll also try to follow up on the safe by design approach and try to give you an overview of what can be done to lower toxicity of graphene-based materials.
Some other question? There was something I wanted to ask to Ralf, actually. So you explained the general principle, as I mentioned, but so as a scientist, I should ask, what's the evidence? Do you have a specific example of a company or of an institution that changed in a visible way its research strategy because of RRI, saying, okay, we adopt RRI, so we quit or we modify this research line?
Yeah. I'll probably have to keep it short.
Until they did not kick us out with the other chair.
Yeah, one company that comes to my mind, it's a company working in the field of precision medicine. And they changed much of their research processes and their innovation management as a result of going through these
Sorry,
RI.
which company is this?
It's a Spanish a small business in genomics, and what they did, they included basically to their procedures a kind of a multi-stakeholder group, which involves patients and other groups, and based on their recommendations, they were able to kind of create new market opportunities for their products, but also change some of their ways they dealt with personalized data, for instance, and things like that. Just one idea. Another is something from two large research organizations in Europe, TNO and my own organization, Fraunhofer. They also started, in the one case, they included a kind of ethics review process because they identified a gap in that area. They didn't have that previously. And in the other case, they kind of opened up to societal actors.
I understand that it's easy to organize, well, not easy, but it's feasible to organize an ethic review. But following that ethic review, did you decide to cut something or change something practically?
I think it's probably too early to say because it's just being institutionalized these days. We'll have to monitor that, of course, and see where it goes, and if it actually changes something, if it prevents some harmful things that haven't been prevented in the past.
Some other question or comment from the speakers? We are a bit running out of time, but yeah, there is one question there. I don't know if it's for Bengt or Ralf or both.
So for Bengt. So my name is Inês Gonçalves. I'm from UNEB in Portugal. I don't belong to the Graphene Flagship, but I'm very curious to know. So you showed there, like that graph, explain the differences between the thickness. So actually the nomenclature of regarding the exfoliation, diameter, and oxidation. So are you in the Graphene Flagship studying safety of those materials, like all of those, or just some? And also, so the toxicity is pretty different depending if it's in dispersion or if it's immobilized on a surface, for example, for surface coatings. Are you also taking that into account? So it's long. If we have to go, we can discuss later. Okay.
Yeah, no, these are excellent questions, and maybe we can. Let's continue until we are kicked off the stage, so I can give you a first answer. Indeed, in the Graphene Flagship, in Work Package 4, we have been studying, we try to populate the whole space of materials that I showed you in this graph. That means materials that have difference in lateral dimensions, difference in carbon-oxygen ratio, difference in number of layers, difference in thickness. These are the three parameters. And in fact, we have a review article that is now in revision for ACS Nano, and we hope that we will manage to publish, where we summarize the first 5 years of work on the Graphene Flagship in terms of all the toxicity and all the ecotoxicity studies. And we also discuss the literature from outside of Europe, from other labs. So it's quite a comprehensive review. But it touches on an important point. In order to do such systematic studies, we need libraries of materials that can fill and populate the whole space of materials. And that's not necessarily the case. So our impression is that the literature can provide answers to some of these questions, but we need to have, but we haven't addressed all the different possible permutations of materials. Much of the research in our work package has been on let's say, graphene flakes, and not so much on coated surfaces, but there are some groups in the work package 4 that have studied, for instance, interactions of neurons with coated surfaces of graphene, and this has been published in several papers. So I agree that if, maybe I misheard you, but if you are talking about surfaces coated with 2D materials, this is also very important. We can follow up later. Perhaps I missed some part of your question.
Okay, now we leave the floor to the first parallel session on fundamentals. I would like to thank again both speakers and you for your valuable question and debate. Thank you very much.